bowtie analysis. I'm Stephanie from WorkSafe Tasmania and I'll be your moderator today. In recognition of the deep history and culture of this island, we acknowledge Tasmanian Aboriginal people, the original and continuing custodians of the land, sea and sky. We acknowledge and pay our respects to all Tasmanian Aboriginal people, all of whom have survived invasion and dispossession and continue to maintain their identity, culture and Aboriginal rights. We ask now that you take a moment to read the following slide about information received today. To interact in today's webinar, please use the chat panel on your screen to type and submit questions for today's presenters. Webcams will only be used by moderator and presenters as well, and today's webinar is also being recorded. It is now my pleasure to introduce your presenters today from the University of Queensland, Professor Maureen Hassel from Minerals Industry Safety and Health Centre, Sustainable Minerals Institute, and Libby Humphries, Research Fellow and Lecturer. Maureen is the Director and a Research Fellow at the University of Queensland's Mineral Industry Safety and Health Centre and UQ Risk. With over 30 years experience in industry and academia, Maureen leads projects focused on risk management, human factors, safety engineering and organisational development. Maureen is dedicated to using research and education to improve health and safety and well-being of workers and workplaces. Her qualifications include degrees in engineering and psychology, an MBA and PhD in cognitive systems engineering. She is also a certified engineer, ergonomist, and graduate of the Australian Institute of Company Directors. Libby has over 20 years experience in health and safety, focusing on developing and implementing management systems and risk management plans, particularly with Rio Tinto and coal seam gas companies. Libby has lived in various parts of Australia, such as Gladstone, Queensland, Juruburu, Northern Territory, and Parkes, New South Wales. Libby holds degrees in psychology, project management, and health and safety. She is passionate about improving health and safety management systems, competency frameworks, and education to enhance health and psychosocial risk management. Libby's educational background includes a bachelor's degree in arts, psychology, and postgraduate qualifications in project management and health and safety, and we welcome our presenters today.
Thank you very much, Stephanie. Hello, everyone. Thank you for attending today. My name is Maureen Hassel, and both Libby and I are going to walk you through this presentation on critical risk control and bowtie analysis. So, as mentioned, we come from the Mineral Industry Safety and Health Centre. The centre has been around for over 25 years. It was established on the after the Maura No. 2 disaster, when one of the findings was that we have a risk-based legislation, but there was not a lot of understanding or education around at that time of what good risk management practices were. So the centre was established to develop and disseminate professional training around operational risk management. We also work in the areas of safety and health, that's both occupational safety and health, as well as systems and process safety, or the more engineering type safety. And the original director was a human factors person out of the nuclear industry in Canada. So the centre has been working on human factors in the high hazard sector for the whole time as well. And the three areas of focus, risk management, health and safety, and human factors, are highly integrated as shown on the screen. So the work that we're presenting today on critical risk control with bowtie analysis is some work that we've been working on for the last decade about how to get better control and why we need better control in our operations. So we've already been introduced, so I'll just skip through this slide, but you'll get the slide pack at the end of the presentation. So if you have any questions after today's presentation, we're available to be contacted. But as Stephanie said, if you have any questions during the presentation today, we're monitoring the chat and we'll answer them as we see come up in the chat. So I like to start my presentations with a bit of an understanding of the history and where things have come from. So what you see on the slide now was the original publication or the earliest publication that I can find on bowtie analysis. It was developed in 1971 at the Riso Institute in Denmark, and this was the publication from that group. What they did is they put a fault tree and event tree together, and they called it the cause-consequence diagram method. They were working on it in Denmark, as I mentioned, and then they presented the cause-consequence diagram in the UK at a conference. And at that time, it was picked up by Shell, ICI, and the UK HSC. So there are publications on the bowtie still as a cause-consequence diagram, but using the term bowtie in Shell documentation. And this is some of the earlier documentation I can find, which shows the publication of the bowtie on the right-hand side. Shell did a lot of work on the bowtie as a cause-consequence diagram initially, and then funded a PhD to develop software to help produce these bowties. That PhD student called the software Thesis, and it was the first illustration of the bowtie using the more linear threat lines and more linear consequence lines that we see today. So here's some other representations from the 90s that show the cause-consequence diagram out of the UK HSC on the left-hand side, and then this is a Lidstone's thesis diagram where we start to see the bowtie lines represented as linear lines on the diagram, and that was for the purposes of being able to program it in software. So the bowtie itself has been around for over 50 years, and both the Shell and ICI and the UK HSC have been working with it extensively over that time and really understanding what produces good bowties, and particularly with the focus of what creates good control on the bowties. So it's from these foundations and the work that we have done here at MISC, working on some risk and bowtie work in the mining industry and with the ICMM, that we're going to share with you today. The bowtie is powerful because it creates a visualization of the whole risk framework associated with managing an event, but it also allows us to do good analysis of whether we've got the right number of controls across all our threats and all our consequences. It also allows us to start to think about whether we've got the right controls, and the controls that we represent, are they actually controls on our bowtie? So it's one of the best methods to do that, both visually as a communication tool, but also as an analysis exercise. And why do we need to do this? Well, if you look at the fatality data, and here's a number of versions of fatality data on the left, it shows the international mining data produced by the ICMM, which is the International Council of Minerals and Metals. On the right-hand side, we see some US data from MSHA and some Australian data. And all that data is showing that when we look at the fatalities that are occurring across industry, we've seen that over the last decade, there's been a bit of a plateau. When we look at the data, the plateau is at numbers that are higher than what we should think is acceptable. So an analysis or several analyses have been done over the years into the data to try and understand why these fatalities keep occurring, because we know over the same period of time that we have put a lot of effort into trying to improve safety. We also know over that period of time, we're not finding new ways of killing people. So the types of incidents that are resulting in fatalities are not new or novel. So we need to find the analysis looked a bit deeper into why we keep having these events. And they happen not only in the safety space where we have fatalities related to accidents, but we also need to look at what is happening in the health space. And we've seen in Australia the reoccurrence of coal miners' occupational lung diseases, and we've had the recent focus on silicosis in the benchtop space, the artificial stone benchtop spaces. And we have a renewed focus across all industries on psychosocial risk management. These are all really important risks that we need to effectively manage and control in order to prevent serious workplace injuries, illnesses, and fatalities. When we look at doing meta-analysis of incidents, and that's when we look at large incident databases and look for what is actually happening to cause these events, we find that, as I mentioned, there's no really new risks. Most of our fatalities are caused by known risks. Most of them are caused because we haven't either identified that risk, or the controls were not in place, or the controls that were in place are not being effectively monitored and maintained. So on the right-hand side of this slide, we see that there are two analyses. Others have been done. These are just two that are quoted here. One was done by the ICMM 10 years ago, and they found that the top factors for incidents are people not properly identifying the risks, controls not being in place, or controls not being effectively implemented or maintained. The same thing that was found by a NODIC study that was done in 2015 for the New South Wales regulator, and they found that most incidents are associated with the failure to implement what should be well-known controls for well-known risks. So in the remainder of this presentation, Libby's going to talk to you about some of the ways that we can do better around identifying the risks, making sure that we have the right controls, and what we need to do to make sure those controls are effectively implemented, monitored, and maintained. Libby?
Thank you, Maureen. Good morning, everyone, or good afternoon if you're elsewhere. Excuse me. So the risk register is a very common tool that I experience and are exposed to across many organisations. And there has been analysis done on the effectiveness of this process for identifying and managing risks. Some of those findings include poor quality lists of unwanted events, too many or too few unwanted events, too many or too few things listed for controls, limited review and critique of controls, no identification of critical controls, a lack of accountability in management systems for assuring controls are implemented and performing as required. So I introduce you to our hazard. So our hazard on this slide is our friend the lion. You can see that our lion can result in multiple different types of unwanted events depending on the scenario. But really what we want to focus on this morning is thinking about the identification of our controls and the effectiveness of our controls. So you can see in the picture we've got our lion on the left. I think the person in the tent might be reading the procedure and how the controls on the left are quite clearly not effective. Whereas our lion on the right has far more effective controls in place. So as Maureen introduced the history of the bow tie, we're going to work through research that has been done over the past 10 years around improving the use of the bow tie tool to allow it to be more operationally effective, to be able to be used as a communication tool across all layers of an organisation, and to help us to be very clear about identifying what our controls are, which controls are important, and then being able to build management plans to ensure the ongoing effectiveness of those controls. So you can see from the diagram, we have a prevention side to our bow tie on the left and a mitigation side to our bow tie on the right. One of the strengths of the bow tie, one of many, is it really allows us to identify and understand the controls that we implement from the point of losing control to preventing the potential for the serious consequence of fatality or disease. So we're going to work through thinking about controls we have in place before the unwanted event occurs and controls that we would identify after the loss of control. And part of this process becomes more effective if we think about how we define our unwanted event and thinking about the identification of our hazard. In most risk registers, I find a column that talks about hazards. If we transition that to an unwanted event, we have the opportunity to be clearer across our workforce about the scope of our bow tie and what we're actually focusing on. Hazards exist in all of our workplaces and in our everyday life, but it's when the hazard is released that we need to ensure we have controls to prevent the release of that hazard, but then to move forward and prevent the potential serious consequence that can result. So working through our bow tie, we'll think about what our threats or causes are. So something that can release the hazard. Then we can think about what controls we have in place to prevent the release of that hazard, resulting in our unwanted event. We can also use the right-hand side of the bow tie to think about what our consequences could be. Now, those consequences can come from our risk matrix, they can come from industry knowledge, but based on our unwanted event, what are the potential consequences that can result if that hazard is released? And then we can think about the controls that we have in place to minimise or prevent those catastrophic consequences. So going back through history, there has been multiple different bow tie formats, and some of you may have seen bow ties that look something like this. There are bow ties that I understand can fill a wall, and quite clearly some of these would be very large if we spread them out to be able to read the font. So we've been doing a lot of work over the last 10 years to understand how we can optimize this process to allow it to become more clear, more easily understood, but not only by our senior people in our organisation, but by our frontline workers. One of the ways that we've been working through being able to operationalise the bow tie is by considering our causes and consequences using categories. So we can think about our causes as being related to the design or construction or maintenance of the working environment. It can be associated with the equipment design and issues or component failures. It can be associated with people not being fit for work or not having the right competency, and can be associated with interaction. So that can be interaction associated with the environment or other activities. With our consequences, we can think about the consequence categories on our matrix. So we think about fatality or multiple fatality. We can think about health and serious health effects or potential fatality in the health space. We can also think about secondary events associated with the release of the hazard. An example of a secondary event could be a fall from height, where you have the potential for trauma if the person is not rescued from a harness within a reasonable period of time. You could have a secondary event associated with drowning following a vehicle accident. So secondary events are important to identify as well. And as we work through this process, quite commonly organisations have processes in place to prevent the release of the hazard and to mitigate the potential consequence. And the bow tie firstly allows us to capture that, but then it also allows us to identify whether we have enough controls. So from the ICMM guidance, and this is part of more effectively operationalising our bow tie, is thinking about how we define a control. So working through the ICMM flow diagram, a control is it of itself a physical object, technological system or human action? Does it of itself arrest or mitigate an unwanted event sequence? And is the required performance specifiable, measurable and auditable? Now, what we find through our interactions with industry is that this definition of a control is quite a significant step change from how we define a control at this point in time. Controls, I find, talking to industry, include procedures and permits, whereas this definition is really focusing on the control being in place between the energy and the threat or the consequence, which is usually the person. So the way that we use this definition to operational our bow ties is by understanding what is a control, but then also thinking about what is a support activity and what is a verification activity. Because those other activities are still very important to our controls being effectively implemented. And it's understanding the difference between what is a control, what activities we have in place to support the health of that control, and what activities we have in place to verify that that control is effective before we commence work. So based on the flow diagram, I have a quick activity for you to complete. So you should have access to a poll online. Let's hope that that's worked. Yeah. No, it's not going to work for me. All right, that's fine.
I can launch that, Libby.
You can? Oh, thank you. Thank you, Stephanie.
Oh, hold on, it's just done something here.
So I'd like for you to have a think about from the diagram on the screen, what is a control in this picture? Is it the driver's license? Is it the driver operating the vehicle? Is it the speed sign? The speed camera? Is it associated with the analysis of data? Based on the flow diagram from the previous slide, what is a control in this picture? That's okay, Stephanie. I can get people to put their thoughts in the chat. So if you can put your thoughts in the chat, I'll consolidate what you put in the chat as to what you think is a control from the pictures in front of you.
So some responses coming through Maureen and Libby: speed limits, signage, again the speed sign, the driver driving at a safe speed, 40 kilometres per hour speed limit, all. Again, signage is something coming through. There really is no control. All our controls, speed sign, licensed driver, speed limit camera, driver's license, again, driver operating, I would say all
Stephanie, thank you.
except.
So I've got a real assortment of responses, things from some people saying everything except the data, some people talking about signs, the speed camera, which is really interesting. And if we go back to our flow diagram, we think about the pictures on the screen. So if we think about the driver's license, is it of itself a physical object, technological system, or human action? I guess it could be. Does it of itself directly is the key word, prevent an unwanted event or mitigate an unwanted outcome? It would have to be a very sturdy driver's license to directly prevent an unwanted event. So if we say no, it takes us to being a support activity. So is it an activity that maximises health or minimises erosion of the control? Well, if we're assuming, now this is really important, that having a licence makes you a competent driver, then possibly yes. And you're very welcome to put in the chat, because only the presenters can see it, whether you think there's a direct correlation between having a driver's licence and being a competent driver. So if then we think about the driver operating the vehicle in accordance with the speed limit, thank you for the person who laughed, is it of itself a physical object, technological system, or human action? The person operating the vehicle, yes. Does it of itself directly prevent an unwanted event or mitigate an unwanted outcome? Yes. The person operating the vehicle, they certainly do. Is the required performance specifiable, measurable, and auditable? Yes, it is. We monitor driver performance in a lot of workplaces. So a control. So the speed camera, a very interesting one. Is it of itself a physical object, technological system, or human action? Oh, yes, it is. Does it of itself directly prevent an unwanted event or mitigate an unwanted outcome? No, it doesn't. So is it an activity that maximises health or minimises erosion of the control? No, probably not. Is it an infield check that the control is implemented? Yes, could be an infield check. So a verification activity. Thank you to the people who supported my feeling around the licence and the competency. And it is a big challenge, driver's licences and competency. Remembering that the intent with this process is for us to make bow ties that can be more operationally effective and be understood by our frontline workers. Being clear on how we define what is and is not a control can help us to make sure our bow ties are more readable and much clearer for our workforce to understand what the controls are and then what the critical controls are to manage that unwanted event. So for you, those of you who desperately want the answer to the question, the driver operating the vehicle in accordance with the speed limit is the control in that picture. And the goal of working through this process and understanding how we break down our bow ties, thinking about how we define our controls, gives us an opportunity to move from the bow tie on the left to the bow tie on the right. And the same with the next slide. So we're really working to move from a bow tie that's very difficult to clearly understand to the bow tie on the right, which is much clearer and very clear about what is a control, and then how we build our critical control management plans to support the effectiveness of those controls. Now, if we refine our bow ties to allow them to be much clearer, we then have an opportunity as an organisation to collect data that can support or inform us as to how we are managing those unwanted events. And this is an example. So we can work through data based around events, incidents, internal, or we have had the opportunity at UQ to access external data to pull together an analysis of where controls and critical controls are failing. So this is unsafe movement of a vehicle, where an analysis is being conducted on lots of incident investigations to understand which controls are failing more frequently, to allow us to understand where to focus our energy to prevent this unwanted event. What is interesting, a point of interest in collating this data and something to take away with you for your investigations is there is limited data around the effectiveness of mitigating controls. So you can see on the right-hand side, there's a lot less information. There's more grey boxes. So the grey boxes are that there was no data available. And the percentages are much lower, purely because the amount of information collated during the investigation did not tend to be focused around those controls that we identify to reduce the potential for the serious consequence after the loss of control. So something to think about in your investigation reports. It's really important for us to understand that if control is lost, we want to know that those controls that prevent the significant consequence are still effective, or where potentially we have weaknesses on that side of the bow tie as well. I'm just going to check for a moment to see if anybody would like to ask any questions.
So there was there was one question that did come through. So Maureen, I'm not sure if you wanted to share the response. So the question was, what is the difference between bow tie method and the fishbone method?
Yes, happy to talk to that. So fishbones are great tools for identifying causes and contributing factors for unwanted events. What they don't tend to do is focus on identifying the layers of control needed to address each of those causes. And they also don't tend to focus on the right-hand side. So what sort of mitigations do we need to address the consequences, or even what sort of consequences might result from the unwanted event? So I use fishbones and teach fishbones a fair bit. So I find them really good at making sure we've got the causes identified on the left-hand side. They're also very good if you looked at one of those controls, for example, the safe parking control that's showing up as the most frequent failure on the bow tie on the screen. If you wanted to know what might be causing that control to fail, you can do a fishbone analysis with a control failure being the top of your fishbone, and trying to identify all the ways, or capturing all the ways that those controls are failing. So fishbones are useful. but they don't give you the controls that you need, or and they don't usually identify the consequences that might result, or the controls that we need on that right-hand side of the bow tie.
Thank you. A very good question. All right, I will move on. So another strength of the bow tie is to work through whether we have sufficient controls. So if we think about our bow tie as a timeline from left to right, we can look at and do our own analysis of our bow ties to identify whether maybe we have threat lines without any controls, or possibly with only one control. And when we're thinking about a fatal hazard, we do need to make decisions around how many controls we would expect to find for a potentially fatal hazard. It can also help us identify if we've got lots of last chance intervention controls and no controls that are more long-term, so are based around the design and construction, that may provide us additional layers of control rather than reliance on our last chance intervention controls. And the same with our mitigating controls. So by thinking about our bow tie from left to right, we can break down our controls into these categories to get a clear idea around whether we have sufficient controls. So you'll see on this bow tie, we've broken the controls around to controls that minimise exposure, controls that detect and deflect, our last chance intervention controls. But then in our mitigating side, we think about protection controls, containment controls, and then recovery controls. After working through our bow tie and identifying our controls and our critical controls, we then work through control assurance management plans, or concept maps, as Maureen has identified, where we can work through using tools to identify how those controls can fail through erosion factors. We can work through what performance measures look like. Sorry, I just have a question that says, what are the percentages in the top right-hand side of each control? So I'm just going to go back. That's this one here. I think I will hand that question to Maureen.
So analysis of this one is, I think, dropped objects or people or objects falling from heights is what this bow tie is about. And I received a large database, 20 years worth of data from Queensland regulator, and I analysed that data in terms of where it sits on the bow tie. So what it was HPIs, as well as high potential incidents, as well as actual events. So what percentage fell on what cause, what percentage fell on what consequence, and then what controls were shown as failing in that analysis. So this is another analysis like the previous one, showing where we've got vulnerability in our control frameworks that are leading to events that we're trying to avoid. So the software is Excel. It's so I use a range of software, but when I'm doing analysis like this, the data usually comes to me in Excel. So I have all the generic bow ties for the common causes of fatalities done in Excel.
So after we've worked through identifying our controls and our critical controls, then we need to clearly understand how we're managing the effective implementation of those controls. And that's when we work through building our management plans around our control management that will consider things like what erosion factors could be. There was a mention of fishbone diagrams. That can be a very useful tool to think about what erosion factors might be for our control. We also need to think about performance requirements. how we maintain and verify that control, but also identifying what our start and stop triggers are. So our frontline workers can be clear how to define when that control is not functioning as intended, and when they actually need to identify to stop work, and what that looks like. So by identifying our controls very clearly, by using those definitions to understand what is a control and what is a support activity and what is a verification activity, we can bring all that information together as a control management plan to ensure the control is effectively implemented. And within our management systems, we need to think about how our control management plans interact with other parts of our health and safety management system. So we've talked about risk and hazard assessment, we've talked about risk control management, but also understanding that our investigation process is a key component to effective management of controls. So ideally, we won't have the serious events, we won't have the fatalities occur. And the critical control process can allow us to develop new triggers into our investigation process that allow us to investigate prior to the loss of control, or also to allow us to trigger an investigation due to other aspects of our control management where we haven't had an event occur, but we still need to conduct an investigation to prevent that from ever occurring. So it's important to think about in your health and safety management system how you integrate that control management process with the other functions of your health and safety management system. So all of the information today has come from some research projects that have been completed by Maureen and the Minerals Industry Safety and Health Centre, and also from the ICMM guidance, which the ICMM guidelines are freely available, so you can Google those and access those documents. Just to close out for the day before I hand over for questions, so I will be back in Tasmania from the 11th to the 13th of December, conducting what we call our GMERM Risk Management Systems course, which is a course that originated within the mining industry here in Queensland, but we have been diversifying that to accept and work through other industries as well, as we want to. And if you talk to Maureen and I, you'll find that we, as part of our personal goals, we do aspire to reduce those fatalities to zero. So I will be back in Tasmania, so you can scan that code if you're after some more information about that course. And I have a few more QR codes to add that you'll be able to access in the handouts that we'll release at the end of the webinar. But on that note, does anybody have any questions they would like to ask myself or Maureen?
So there's one here. Do you treat and manage the critical controls differently compared to standard controls? Assess them more frequently. Critical controls are treated differently from standard controls. All controls need to be monitored and checked. Critical controls get an extra layer of governance. So with critical controls, we want that independent check done on the control. We also ask that that independent check be done by somebody more senior in the hierarchy. So what they're doing is they're checking the control. They're also checking that those frontline checks are happening at a quality, in a quality manner and in a timely manner, and that the people that are relying on the controls to save them or to keep them safe, understand what good performance for that control looks like and when they should stop and what they should do for a stop rule, if a stop rule is triggered because the control is not performing as it should. The critical control checks also by senior management should also involve the determination of the true effectiveness of the control. So whether it is actually effective in either preventing the unwanted event or mitigating it. So that often not only involves talking to the frontline workers and supervisors, but also referring to the data that exists on the control. There's another question here. Is the bow tie a graphical representation or related to an FMEA? So FMEA is a failure modes effects analysis. There is a relationship between the left-hand side of the bow tie and a failure modes effects analysis. But also a failure modes effects analysis is a good way of understanding how controls fail. So it is can be used to complement the bow tie, particularly if you've got a control that's a critical control. You want to understand, as Libby said, the erosion factors, the things that could lead that control to fail, to make sure that you've got support activities addressing those factors so the control doesn't erode over time or fail catastrophically, because these controls we are relying on to prevent fatalities. So to understand how the controls might fail, I think that the FMECA or FMEA process is a great way of doing that. There's the equivalent, so FMEA is historically been biased towards equipment failures. If you've got a control that involves human action, like human responding to alarm, then the STPA is a human factors version of the FMEA. So the philosophy is still the same, trying to get to the failure modes, but the STPA process focuses on human actions. The FMEA process is very, traditionally anyway, has been very equipment driven.
And there's a comment that's also come through, Maureen and Libby. At the moment, we are dealing with procedures, controls, and new paperwork that are inadequately consulted, inadequately thought through, and with little understanding of the impact on workers. We begin with it on Sunday and still don't know what we are doing.
I'm not sure what the question is, whether it's where to start or, you know, I'm happy to take that offline and understand that a bit more with that one. And both Libby and I are happy to engage with anyone on online after this seminar if you want to talk in a bit more detail. I think that one I need to understand a little bit more to answer it. Also,
Okay.
Sorry, you go.
No, I was going to say just another question if you're happy to continue with a few more.
Yes.
Yes. How would you summarise linking this back to risk registers?
So that's a
that may
great
link back.
question. Yeah, that's a great question. So your risk registers should be capturing your unwanted events that are significant, and the significance of those. For those unwanted events that are significant or material, then you should be doing the bow tie analysis to identify the controls. Now, the risk register section that's allocated to controls, you can either then refer the reader to the bow tie, or you can list the controls that you've identified on the bow tie back in those registers. I often find it's easier to link the registers to the bow ties that you've done. But the bow ties themselves won't identify the events that you should be doing bow ties on. It's the process that sits that's used to generate the risk registers should identify what those unwanted events are that are material enough to warrant a bowtie analysis.
All right, thanks, Maureen. And what should the team who is investigating an unwanted event, a hazard, using bowtie method consist of in terms of roles?
So it's really important that it is a consultative process. So I'm glad that question was asked. So the team, anything associated with unwanted event management is a team activity. So you want a cross representation of the workforce. You want maintenance people, you want operations people, you want supervisors, subject matter experts. If there's engineering involved or some sort of specialist competency involved, you want them as well. What I've seen happen is people have assigned the risk, the unwanted event, to a risk owner. So they also need to be involved, and they also need to own the product, the bowtie that's coming out of it. And some of the larger organizations also think about critical control owners. So if you've got a material unwanted event that you're doing a bowtie analysis on, and you're thinking about what the critical controls are, you might want to have some of the people who may be the owner of those controls involved in that process as well.
Thank you. Are you able to comment on the hierarchy of controls?
I can comment on the hierarchy of controls. So the hierarchy of controls is, there's a couple of forms of the hierarchy of control that exists in publications and exists across disciplines. So typically they do capture elimination, substitution, engineering type controls, administrative type controls, and personal equipment controls. So the categories of control, the categories of ways of managing a hazard are, as I mentioned, the elimination, the substitution, and implementing controls. Now, often hierarchy of controls is used as a proxy for determining the effectiveness of controls. That is where, if you do that without considering what is the actual effectiveness of the controls, then it can become problematic. So I've been exposed to situations where people think that they need to go to engineering controls because they're more effective, when they may not be the most effective control. Examples of that is when we think about fatigue management, some of the really effective controls are your rostering and your scheduling of your breaks, which sits in the administrative area, and that's more effective than any technology that I've seen around fatigue management. So another area is working at heights. In some scenarios, wearing the PPE, the full restraint harnesses, is the most effective control at preventing fatalities, and not the engineering controls like getting into a elevated work platform. So the hierarchy of controls can be useful in helping us think about what is the range of controls, and yes, thinking about whether we can eliminate or substitute the hazard first and foremost. But don't automatically apply this blanket rule that engineering controls are more effective. The other problem with it is most controls that we use to manage our serious risks are actually a combination of engineering and administration and PPE. So they don't neatly fit into one category. So again, use it as a reference to help us think about the range of controls, but don't blindly assume that one category of controls is more effective than another. The question about bowtie work with ICAM investigations, the short answer is yes. So I really encourage the use of bowtie in any sort of investigations, and definitely in ICAM. It produces really good insight, and ask not only what controls have failed, but ask also what controls have worked in an investigation. It gives you the opportunity to go out and, just like you saw some of those bowtie analysis that was produced, it asks you, it's an opportunity to find out how the controls, all controls performed when they were tested or stress tested in the event. So don't just try and focus on what was the cause, but focus on what were the controls that were present or absent. For those present controls, what was effective and not effective. And you can get some really good insights on them. And for the controls that weren't present and should have been or weren't effective, you can then drill down into why as a part of that investigation. And everybody has a slightly different version of ICAM and processes they use under the ICAM label. But most of the ones I see allow you to slot in that bowtie. There's also a comment here about risk registers appear to focus on administrative controls. Yes. I've seen registers, and as Libby put up on the slide, you know, there's a lot of problems with that register type format from a human factors perspective. It focuses on us getting something in the boxes rather than thinking about the quality of the something that we put in the box. And it's not very good on controls, and there's no checks on those controls. So that's a part of this work, is trying to get more rigor. And that's why we show those decision trees about what is and what isn't a control, and get some more rigor also in making sure that we've got the right layers of control, both to prevent the event as well as to mitigate it. Because that's another problem I've seen in the registers, is that there's no checks on, you know, have we got the right balance of prevention and mitigation controls as well. Is there any more questions?
Nothing that's come through at the moment, Maureen.
Okay. Well, as I said, we're available to be contacted. Libby's got put our details up. Happy to do that, and we're really motivated. Sadly, we just had a fatality here in Queensland in the last day or so. So one of our focuses is on that fatality prevention. We're happy to help where we can do that, and thanks for the opportunity for giving this presentation.
No, thank you very much. And so thank you everyone for attending today, and we'll now share the presentation for you to download. As well, this webinar has been presented as part of WorkSafe Tasmania Month. Please head to worksafe.tas.gov.au to see what other webinars and in-person events that we are running here throughout the month of October. Today's webinar has also been recorded, so please head to WorkSafe Tasmania's YouTube page to rewatch today's webinar, share today's webinar, or watch other webinars that you may have missed this October. So thank you again to our presenters from the University of Queensland for their presentation, Critical Risk Control with Bowtie Analysis. And thank you for everyone for attending, and please have a safe and healthy day. Thanks.
Thank you. Goodbye,
Thank you.
everyone.
Bye, everyone.